Yeah, what are you doing today, Jim?
We are installing a new capillary dial thermometer for the smokestack on Jimmy's Evaporator. This is a very, very old Corsair. It's one of the first Corsairs ever made. It belongs in a museum. So we have this part mounted. This is a brand new product. It's as of 4/1/21. It's not even available on the website. It's something that will be very mainstream for the 2022 season. By midsummer of 2021, it will be on the website. I can't say for sure that this is exactly what your mounts are going to look like, but this is what the capillary dial is going to look like. And we have two different sizes.
What size is this?
That's a 4-inch.
That's really nice. I can read it from far away.
Yeah, and the 4-inch model comes with a 10-foot lead on it. So this is the 4-inch like we're installing on Jimmy's old Corsair here. That's how that comes, minus the mount. The mount is going to be in addition to what you see here. Then we also have a real jumbo daddy.
Jumbo daddy.
So that's a 6-inch dial.
How big is it compared to your head? Whoa.
Yeah, I mean this is.
And you've got a big head.
Yeah.
I got a big head too.
Oh.
Look at how big it is. Look at how big it is.
Yeah.
So with the 6-inch dial, you get a longer lead too. The lead for the 6-inch dial is actually 17 feet. So if you have a big evaporator, and it's important to you to have the dial up toward the front of the evaporator, that might be one reason to get the bigger dial. Other than it's easier to read and so forth. But same thing comes with the heavy-duty probe, 1/2-inch NPT connection.
So you're gonna install this on Jimmy's legacy model
his
here.
His old relic Corsair, yep. And so this part's already mounted. We're keeping it away from the draw off. We're putting it on the side of the evaporator where it's going to be most convenient to see. The other side of the evaporator, there's a switch and so forth for his force draft. But now let's mount the probe.
So what kind of drill bit you got there?
This is a step drill, and in Jimmy's smokestack he has a tiny hole from a different type of thermometer that failed. So we're going to use that same location and we're going to drill into it. The range of the dial goes to a maximum of 1200 degrees. Beyond that, the needle would keep on turning, but the last definitive number is 1200. So if you're like Jimmy and you like shooting a blowtorch out of your smokestack, that might not be...
Is that true?
It's harder now. But
he runs it hot. He has force draft, good dry firewood, and only a flat pan, so there's not much absorbing the exhaust from the fire. So in Jimmy's case, if he's exceeding that 1200 degree mark, he might want to raise it up higher yet, but we'll try it where it is now. The number which is displayed doesn't matter. What this does for you, it gives you a baseline to run your evaporator. It gives you a benchmark for when you should be adding firewood, and it allows you to run stable. And I can tell you that after running any evaporator with this information of knowing your smokestack temperature, it would be tough to go back to not having it. It would be like you taking the speedometer out of your car and trying to calculate in your mind based on your RPMs how fast you're going and what gear you're in. This is very important information, and once you have that, you wouldn't want to go without it. It's super to have. We've always had some availability of this. We've had the temperature display for the smokestack on our Great Lakes Guardian auto draw-off system. Well, not everyone wants to invest in an auto draw-off. Not everyone wants to run an auto draw-off, but this is important information, and it's coming now finally for the first time in the maple industry at an affordable price for a reliable product.
I like your analogy about the car because, I mean, we already have a peep window on the firebox, you know, but I mean, I can see, oh, okay, the flame is dying down. I should probably add firewood, but it's kind of like driving in a car. I can look out the window and tell, hey, I'm going pretty fast, but I don't have an odometer telling me definitively how fast I'm going.
Yeah, speedometer, right.
Exactly. Or speedometer, yeah, sorry.
Yeah, you're right. The PEEP window gives you information. It gives you good information. This gives you very definitive information.
Yep.
Especially when you're stepping away from the evaporator, you've been running it all day, and someone else is going to take over for you, or you're teaching your kids how to run it. It gives you a baseline. Instead of letting the fire die down too far, everyone knows the consequence of that. Or I guess on the other end, it can't really get too hot. But basically, it gives you that benchmark of running it. So you can, as you're teaching someone to run the evaporator, whether it be your kids or on a large scale your employees, you're teaching them how to run the evaporator. Now finally you have that information at your fingertips. When you see the temperature get down, let's just say down to 900 degrees Fahrenheit, load some wood.
Yeah, it's not subjective anymore.
It's not so subjective, yeah. Or the number might be when it gets down to 750 degrees Fahrenheit, load some wood.
Right, so it's going to be different for every person.
Yeah.
Right.
But I feel like it could also indicate wood quality too. If you
we're looking forward to it for the customers that we have. We have a couple every year who say, "I'm not getting the performance out of my evaporator." We run into that somewhat frequently with thousands of evaporators in the field. We get those people that can't get their performance up. Now, for a small investment, they can install this unit, and we can start figuring out what the problem is. Well, if you're not getting a stack temperature of more than 600 degrees, well, now we know things aren't hot enough. Let's look at your firewood. Let's look at combustion air. Yeah, let's look at stack height. Let's look at other options to fix this. Everyone says, well, it's hot. Well, yeah, it's hot. It's going to burn you if you touch your pipe, even if it's 300 degrees. But now we have numbers. Now we have information that can actually start helping people make better choices with their firewood and so forth. Up until now in the maple industry, there's never been a thermometer system other than some of the very expensive digital ones that really fit the bill here. And now we have it. Now we have a really, really cool solution where we can have a remote display system and a very reliable, rugged probe.
And some people in my preference in some cases, I like analog.
Yeah.
It's a little more traditional. I've got ball valves to run things, and I'm manually drawing syrup. So if that's the way you want to run, I just like the reliability of it sometimes and the simplicity of it.
Me too, and especially same note when I'm manually drawing syrup off, I hate watching a digital thermometer. I don't know how you feel about that, but when I watch a digital thermometer, the number is jumping 218.6, 219.2, 218.9. That number is jumping all over dramatically, even though it's only representing a half a degree or maybe 1 degree. It's jumping in a way where it's hard to watch. With a needle on an analog draw-off thermometer, that needle is just stable, and it slowly works its way up to the point where you have a target to open your valve and draw off.
Yeah, it's not so fatiguing.
It's just easier to use. And after you open your valve, you watch the needle slightly rise up and then slowly go back down, right when to close the valve. A digital thermometer is very frustrating for me to watch at the draw off if I have to manually draw off. Same thing with this. I can't wait to watch this thing working. It's going to be really cool.
In a short amount of time too. We're going to stuff the firebox and load the wood here in a little bit.
Yeah, real quickly we're going to be doing that.
All right,
but let's install this probe. This is as you can see, this is a very rugged probe. We're using a 1/2-inch NPT connection here, and that is supplied with it. So let's drill our hole. I'm gonna drill at the same location here through his stainless steel pipe. And yes, everyone, this is stainless steel pipe. Jimmy runs his smokestack hot, and I like it. I like running an evaporator hot and aggressive. I think that's cool. It's fun to get things done.
Rawr.
Yeah.
So Jimmy, tell me about this last stack temperature. Oh, maybe
So
not.
the last stack temp probe was a very small, similar style analog thermometer. It capped out at 1,000 degrees, and it was always kind of like if it came back into the range of 950, 900, we would load wood, but it was pinned where we think typically it was running somewhere between 1,200 and maybe 1,300. But it was past that amount. So, I mean, where we're doing this with this and putting this in, that extra 200 degrees is going to be nice to give me that extra range.
Yeah. Plus, I don't know, was the one that you got intended for
I don't know
a
if
maple evaporator?
Technically it was, but it really is not the right design because it worked good that first boil, and then the second and third boil, all of a sudden the needle was just spinning, and so I could no longer trust it. It was all of a sudden moving past that temperature where it would stop. So it lasted basically about an 8-hour boil, and then from there forward it
could handle the heat.
Could not handle the heat. It was toast. It was
torched. And that wasn't analog. You said it had,
Yeah.
So
I think the problem with that is those are generally driven by a bimetal coil, which is very reliable. Like this here, the draw thermometer, that's a bimetal coil.
Mm-hmm.
Very reliable, but in the atmosphere of a smokestack, it's just too hot. And I can't see those bimetal coils. Like I said, they're bimetal. They're not all stainless steel. There's several metal components within that coil which actually drive it. The temperature differential in that coil is what drives the needle around. And they just can't handle that temperature. So now we're using a gas-driven device. So much more reliable. It's incalculably more reliable and rugged. But all I did was I cut a hole with that step drill just big enough to get my thread started. That way as I start turning the fitting in, it's gonna just jam tight because it is a tapered thread fitting. It's a 1/2 inch NPT, so it is a tapered thread. As I thread that in there, it's gonna jam up and fit nice and tight. Every installation is going to be different. You might have a much longer evaporator, you might have a galvanized smokestack, but this is a solution that is going to fit all of those different systems.
So you chose not to go through the base stack. You wanted to go through the cylindrical.
Well, you can pretty much go anywhere you want. And on Jimmy's evaporator, I didn't want to go in the base stack because he does run it so hot. He doesn't have a flue pan to absorb the heat from the exhaust. If anything, I would have gone higher. The reason I went here is because he already had that small hole from a previous thermometer. And look at that, an American-made Craftsman. I like it. So I'm just going to thread it in there as best I can by hand. And it's not going to take a lot of force to thread it in, but I would thread it in all the way by hand, but I don't want to round off the nut. But it's sturdy and strong, so I'm already proud of it. A little bit of never sees on these threads sure wouldn't hurt.
You'll get some? Sure.
If you had some handy, yeah. I'm just going to thread it in there by hand for now.
So that would be because it's a stainless on stainless threaded connection.
Yeah, and even more important is when it's hot. Stainless on stainless is always a bad deal. But now we're in a situation where it's going to get extremely hot. And if you ever want to get that apart, I think never sees better be in that equation.
The anti-seize we're going to use 2,400 degrees apparently. It's
all right.
rated to.
Yeah, most never sees can handle pretty good temperatures, so that's a good one if it handles 24.
So you're going to have someone ask if they can cut that lead to make it shorter.
No, you can't. Nope, that's a gas line. It's of course it's a non-flammable gas, but no, you cannot cut that. So whatever extra you have,
coil it up.
Coil it up. However you want to do it. I'm coiling it up back behind the thermometer, and no doubt Jimmy's going to do something neater once he has time to do so. But we're looking to get her fired up right now, though.
Yeah, we'll clip something up later.
We got the pan nice and clean, Jimbo.
Yeah, we had about 500 gallons through it before I decided to do a cleanup.
Mm-hmm.
We did an early season kind of cleanup, and then we did that 50-50 vinegar soak, and just works out really well, getting a nice
You might be the only guy left that lights his evaporator without a blowtorch.
A match? One match is all a guy needs.
So we just lit the fire, and wow,
Yeah.
it's actually climbing super fast.
Yep.
We're outdoors, so the syrup in the pan is starting out pretty cold.
Got a roaring fire going on here.
He opened up the firebox, so temperature inside is dropping. But we're adding more fuel.
That was a big charge of wood. I think we're going to bury the needle this time.
Let's see how we can recover. Ooh-wee. It's climbing.
Wow, yeah, you're going to need sap soon.
Not right away, that's pretty high.
This is good information. What he's doing here is giving it the ultimate torture test. He's got a flat pan on a short evaporator with forced draft and very, very dry firewood. And I figured he was going to bury the needle on it, especially that last charge of wood. What's most important, I think, is what it comes down to when you fire. That's the information you're looking for, is to fire regularly. And I don't know if it's only been on here for 20 minutes, but you'll eventually develop that pattern where you're firing at 900 degrees or 1100 or 800 or whatever it's going to be.
Yeah.
Very, very good information.
So you're saying that the stack temp is hotter because he's got a flat pan, and that's because a flue pan is able to transfer more heat into the sap.
A flue pan is inherently more efficient than a flat pan because it does absorb that heat from the exhaust before it gets to the stack pipe. So a flat pan has very little ability to pull that heat out of the
firebox.
Plus, it's short. You know, the firebox is only a couple of feet away from the stack pipe, and there's flames going right up that stack pipe. And you've seen Jimmy's evaporator running at night. It looks like a blowtorch coming out of the smokestack.
So a longer, skinnier evaporator. Since all that heat has more distance to travel,
Yep.
more heat's being absorbed into the sap,
Right.
transferred into the sap.
A long evaporator is inherently more efficient, definitely. Yep.
So how does a person choose their stack temp?
They need to learn from experience over the course of hours or days what they need in terms of remaining burning fuel in the combustion chamber when they add wood. There's a penalty to letting it burn down too far. When it burns down too far, the recovery time is way too long. Like when Jimmy just added that wood, it was a good sized charge of wood, but when he loaded that wood and hit the blower, the temperature went up. At this height of the stack pipe, the temperature went up over 1200 degrees almost instantly, and the boil was there instantly. So not letting it burn down too far is the most important thing. And by the end of the day here, Jimmy will have a baseline, a benchmark where he wants to start adding firewood.
I typically find that for me, loading wood, I like to keep the box about 2/3 full. Seems to be like a good ratio. 2/3 down to 1/3, and then cycle that every 9 minutes is about what I do to add.
Yeah. And now there won't be any guessing at all. I have a feeling you're going to find somewhere between 900 and 1,000 is a good time to probably add wood, but you'll know that in a matter of hours.
Every time you open the box, you're losing that heat too, so you have to kind of balance that.
That's the other thing to weigh in. What temperature are you looking for? To find that, I can't give you a temperature because every evaporator is different. If this was a 2x6 evaporator, we would never get near 1,200 degrees Fahrenheit because it is longer. It has more surface area absorbing heat. So there is no definitive number for anybody. A Starcat and a
Dauntless would be way different.
And a Dauntless are going to be way different. Any evaporator with a flue pan is going to be different. A long evaporator is going to be different. A wide evaporator is going to... There's too many variables. What you need to do is find that happy medium of not burning your fuel down too far, but not opening your door too often. Like Jimmy said, if you're opening the door too often, every time you open the door, your boil pretty much gets killed completely. So
And the other thing to think about is when you get to a point when we're going to reestablish the gradient by bringing some fresh sap in a little bit, what's your cycle on adding, you know, when are you going to load wood and then when are you going to draw? Because you want to put those together. And, you know, usually you want to load wood just before you see. So if I'm watching my thermometer climb here and I'm getting close to that, you know, 7 or 8 or 8.5 mark that I might draw at, when I get close to that, then I know, hey, I'm coming up on a draw. I can see that. So then I'm going to want to load wood before that draw. And then I'm going to adjust the amount of sap coming in. And then, so load wood, adjust sap, and then open that draw valve. And that seems to be really good for us staying consistent in a manual draw scenario.
So you want to increase the sap flow because you know you're about to be drying off and pulling off. You want to maintain your
And a float box, of course, automates that side of it.
And if you don't have the float box and you still like the manual, I mean, a sight glass is still, I think, essential for trying to keep consistency.
I do too.
You know, and I've got mine set up on the back end.
So a neat observation that I already noticed. So you loaded wood and it went up past 1200.
Yep.
And then it fairly rapidly came down to the point where you're at now. You're at
about ready to load now.
About 950, and I feel like you're ready to load.
Yeah.
So I think 950 is probably going to be your number.
It's going to be a good number to stack.
See, Jimmy got all his wood down on the ground where he can access it, so he's not wasting time with door open.
Yep. Yeah. It's a common thing for us to stack the wood, then get the door. And
yep.
Sometimes somebody even gets the switch for you. Now we're going to climb back up. That was a lighter load, so I don't expect to go quite as high. And
maybe not. Yeah.
But it should get pretty close. 1200.
Yeah, it should. Yeah. And that's perfect. I can hear the flames up in the smokestack.
So I know our friend Larry would never have a stack temp that high, just because his sap jumps out of his pan. So the amount of just keeping the sap in his pans is what dictates his stack temp.
Yeah, I believe so. And he's got a long, narrow evaporator too. It's pretty tough for him to get to 1,000 degrees even. That would be very tough.
Yeah. So, like you said, everybody's got a different scenario, a different evaporator, different.
And also, everything is relative. Your stack temperature here is probably 500 degrees higher than it is 4 feet up from there.
Right.
The flames are intimately contacting the probe here. A few feet up, they would not be.
Mm-hmm. So what did we learn here today, Jim?
So we learned that Jimmy runs a really hot evaporator, and we already knew that actually. That's good. Seems like Jimmy's firing anywhere between, I think last time it was like 1050, and I think that was comfortable, right? You didn't want it to burn down.
1050 to 1100 seems like my target.
That's going to be his range, and that didn't take us long to establish that.
No.
But the evaporator is warmed up now. It took a good half hour for the bricks to get warm, and I have a feeling if you watch it, you're probably going to be loading somewhere around 1100, and that's good. That's all we need to know. And there you can actually see in broad daylight the smokestack is glowing red. I don't know if you can see that right there, but to see that in broad daylight, you know things are darn hot. And I can't get much closer than this right here. I don't want to be much closer than a couple feet away from that pipe. So that's a hot evaporator.
So when it dips down to, what did you say, 1,000?
Last time he loaded it was about 1050, 1050 Fahrenheit.
And so then, like, sometimes you say, you have to load every so many minutes. Well, maybe, maybe not.
It depends on what your wood is. Because you have a mix there. You have some lumber, you have some hardwood, you have some basswood. Yeah, here's some ash. And, basswood, pine. So depending on, plywood. So depending on what he's loading, the timer doesn't work. Right. He really needs to rely on something that is actually monitoring what's going on in the combustion chamber. So that's a good example. Look at all the different wood that you can throw in. And that changes as you go through your wood pile too, I'm sure.
Yeah.
It does for most people.
The inner row and the outer row might test a little different in moisture.
Yeah.
If one was exposed out more readily available, it's going to dry quicker. So.
And at one point in your wood pile, there might be a hickory tree, and then on top of that, there might be a maple or another basswood. So
yeah,
this is what's giving you the information that you need, no matter what is going into the firebox. And Jimmy is loading at 1050. He's definitely on the upper end of the spectrum of how hot an evaporator runs. Probably at the tip of the spectrum. Flat pan, short evaporator. Yeah, so we've only been here an hour, and I think you have a pretty good benchmark for what your loading temperature is going to be. That might alter a little bit here as you boil tonight. But
Yeah.
And what are we gaining now that we have all this information? What are we gaining?
We're gaining fuel efficiency. We're gaining productivity. We're gaining gallons per hour, and we're gaining ease. It makes it so that any person in the crew can load the evaporator based on the loading temperature.
Very nice, Jimbo. Yeah.